function with the denominator. That was the misunderstanding on y'all's bonus question on your quiz the other day. I'll make sure I clarify it. I feel like I said that already. Am I having deja vu?
Deja.
Alright, Joseph. Okay.
Okay.
Contentious. Okay. Range. It's a much more difficult question to answer the range here. If you have a good picture, you might be able to tell. What I'm going to do is just put a little star by that range because I'm remembering that if I can make it to the end of this process, the very, very end, I'll have a function, right? An inverse function, whose domain I'll probably be able to pinpoint pretty quickly based on my growing skills in pre-cal. And if I can find the domain real fast of my final answer, I will then be able to have the range of the original. Remember that switching behavior. We'll revisit that in a second. Step 2, I want to get to the good stuff because I'm sure I'm running out of time. Y equals x minus 1 over x plus 2. I think some of you can already envision why this is going to be a little more rigorous than the one that we just did. 2 x's over there. Bless you. When I switch my variables, I get an x equals. But over here, both of those x's need to be replaced with y's. Oh, I'm trying to really be good with color today. And that's a much more rigorous situation to deal with than what we had before when all I needed to do was move 16 and take a cube root. This process will probably entail like 9 steps. I'm just being real with you. So get ready. That's why I gave you a whole page. I know. Okay. First things first. Can we all kind of collectively agree that fractions suck? We don't like fractions, right? Let's get rid of the fraction. To do that, I just need to hone in on the denominator and multiply both sides by what I see in the denominator. We're going to start with that so at least I don't have fractions in my way. I'm going to multiply by a y plus 2 because that's the denominator. And I'll multiply over here, by a y plus 2. This is super exciting on the right-hand side because these things cancel. And come up here so we can see. On the left-hand side, there's a product that is formed, right, by that move that I just made. I'm going to just write that in a more clear manner. I'm going to have the x, the single term, and I need to multiply that by what I just created, the y plus 2. And on the right-hand side, I've got a y minus 1. Whoa. Listening to that little algebra voice inside of your head that I know you all have, what do I want to do over here?
Divide by distribute.
Distribute first, okay? Feedback from those quizzes the other day, many of you are great at distributing the first time, and you forget to continue multiplying on the second term too. Make sure both things are multiplied. X times y.
X, Y.
X, y, unfortunately. X times 2, 2x. And then I got a y minus 1. This is funny. I was doing this last class, and someone was in the room, like, watching me teach and stuff, and so I had to, like, filter. But when I did this first period, I said a bad word, because a bad word helps me when I do this. And y'all are going to giggle at what my version of a bad word is. But when you get to this stage, can you agree that there's a problem here? There's more than one term with a y, right? So my analogy, is that the y terms, which there are 2 of right here, those are like gold to me. I want to solve for y, right? So that's the really valuable stuff of the equation on my page. And gold is more valuable when you have more of it, right? So what I want to do is try and get the gold that's separated right now together so that it's worth more. So in a minute, I'm going to move this y over here so that all my gold is grouped together, okay? Everything else on the board, though, when I had the other person in the room, I called it fake gold, and it was fine. What I usually call it is crap, because you know fake gold, it's just crap, right? That's the bad word that I'm going to use today. I'm sorry I said crap. I will continue to say it. The 2x though and the -1 are not nearly as valuable to me because they don't have the y's in them. So I call those crap. And I don't want my crap to devalue my gold, right? Like gold I've got to keep isolated. It's special. It's worth more. So this 2x or this piece of crap that I have right here has got to go right now. Two things have to happen then. I want my gold together, and I want my crap as far away from the gold as possible. You good? It sounds funny, I know. Okay. If I want to move this y over to the other side, currently that y is positive. So to get rid of it, Dulce, what do I want to do here? I want to subtract the y. Minus y and minus y. This is confusing for some folks because when Dulce said subtract the y, we know that that is the motivation behind that is so that these cancel. And I don't know if you can anticipate, but a lot of students make a mistake right here because they try to cancel them here as well. And I get it, like you see a y minus a y. However, the one on top has an x with it, yes? So I cannot cancel anything right there. I just have an xy, now minus another y. And I'm excited because that's really valuable to me, and my gold is together. But I still, unfortunately, have this 2x crap that's in my way, and I need to get rid of that so that my gold is together and my crap is together. You can giggle, it sounds fun. This is a positive 2x, so just like Dulce did the first time, let's subtract that to get rid of it. And I know that it might not feel like we're in a much better situation, but we really are. When you compare what we have now to what we started with, the fraction is gone. All of my y's are together, and I'm in a place where I'm really close to being done with this problem, okay? The major strategy from here, though, for some reason, no matter how many times we do this, it never quite becomes natural to students. So if we get stuck, this is generally where it happens. My whole motivation for grouping my gold together is so that everything that shows up on the left-hand side of the equation contains that special y in it. And in mathematics, when terms are together on one side of the equal sign and they share something in common, we can always do something with that common term. Anybody know where I'm going with this? Crickets. That's okay. That common term every single time can be factored out. I'm going to factor out the y right now. And a beautiful thing happens when I do that. Let me come up here. P.S. By factoring, I mean that common term of y, I'm going to put outside of a parenthesis, because that's the most valuable thing right now. And I've got this other stuff, -1, sorry, minus 2x over here. And I need to figure out what happens when I remove the y from both of those terms right here. You've heard about this, like diamonds in the rough, right? They're really impure and they've got a bunch of junk in them, and so some jewelers in different places clean them out and get them in their purest form. That's what we're doing right now. We are taking out the y here to get rid of that crap that's attached to those y's. So what I'm going to do right here is ask you a question. If I get rid of the y, what's left over? X. Okay? Another way of saying that is y times the x would get me back to xy over here. I can't really frame it the same way. If I take the y out, what's left over? -1. Oh, good. Sometimes when I ask that, people are like, nothing, and I'm done. No, there's a -1 right there. So I say it differently. Y times what gets me -y, and now I see clearly the -1. And I'm so close. I know this feels like the longest problem ever, but right now, I've done something huge mathematically here. I have gone from 2 y's, an expression that has a y showing up twice, to an expression that has a y just showing up once. So now when my goal is isolate y, I can actually do this.